In this video, I want to talk about rational exponents, meaning when you have a fraction in your exponent. When we have a fraction in our exponent, when we have rational exponents, what that's actually referencing is having a radical of some kind, having some kind of type of root. And so you can see that with this property that I've written right here. We have the nth root of x to the a power is equivalent to x to the a over n power, meaning x is your base in this, and then on the left side here, that base of x has both an nth root and a power of a going to it. And so instead of having both an exponent and a radical, making us feel like we have two things to keep track of, we can rewrite that as just an exponent that happens to be a fraction. So to put a number example with it, if I said that you were doing the third root of x squared, and I said I want you to express that as a rational exponent. Well, the idea is when you have a fraction, you've got a numerator and a denominator, right, a top and bottom. So the numerator of that fraction should represent the regular exponent, the power that you were already raising it to. The denominator of that fraction should represent the type of radical, the type of root. So if it's x squared, that means that 2 is still going to be the numerator. It's still going to be the first thing that we put for our exponent. And then the denominator is going to be based on what type of root we have. Meaning since this is a third root, a cube root, we put a 3 for our denominator. It's not changing anything, it's just expressing it in a different fashion. So to go the other way, let's say I asked you to figure out what 27 to the 2/3 power is. Well, if I asked you to figure out what 27 to the 2/3 power is, rather than asking yourself what that is just, off the top of your head, what might be easier to solve that out would be to change that from exponential form, rational exponent form, into radical form. So 27 is my base, so 27 is what I'm going to have inside the radical. And then it's just between the 2 and the 3. The 2, being the numerator, would represent the normal exponent, meaning we have 27 being squared. The 3, being the denominator of that fraction, means that it represents the type of radical, the type of root. So we have the third root of 27 squared. Now here's the other interesting thing with this lesson. We just talked about that you can write a radical as an exponent. You can express a radical as an exponent, which means we can consider both radicals and exponents to be the same step in our order of operations. And the significance of that is that when you have something like this, where it's the third root of 27 squared, it is entirely up to you whether you would like to third root 27 first or square 27 first. So like for me, I don't necessarily know what 27 squared is right off the top of my head. So I would probably prefer to do the third root of 27 first, because I know the third root of 27 is 3. Then I still have to square, and so 3 squared gives me 9, my answer. Or maybe to show you a better one that might be easier to do off the top of your head, let's say it was 4 to the 3/2. So we wanted to express that as in a radical form. Well, 4 is the base. 3, being the numerator, would represent the type of exponent. 2, being the denominator, would represent the type of radical. Remember that a second root is also known as a square root, and you don't have to write that 2. So you can just leave it blank, and we would assume it's a square root, or you can put the 2 to, be clear with that. But if you're doing the square root of 4 to the third, it doesn't matter which way you want to do it. Let's say you decide that you want to take 4 to the third first. Well, 4 times 4 is 16. 16 times 4 is 64. But you'd still have the square root left because you haven't done that yet. So what's the square root of 64? Well, that's 8. But let's say instead, you'd rather square root 4 first. Well, what's the square root of 4? 2. But we still haven't taken anything to the third power yet, so that's still there. And what is 2 to the third? Also 8. That's the nice thing with this, is if you have a radical and an exponent, it doesn't matter what order you want to do that in. It's your choice. Now let's talk about how to apply this with solving equations. Yes, I do have the same equation written here twice. We've talked about how to solve equations like this in the past, right? If I just said x squared equals 4, how do you solve that? I imagine most of you would probably answer, well, let's square root both sides, because that's the opposite of squaring. And you're accurate. The inverse of squaring would be to square root. So if we square root both sides, the square root of x squared is x, and the square root of 4 is 2. Now what hopefully you remembered is that we've talked about in the past that the answer is not just x equals 2. The answer is x equals both positive and negative 2. Because there's an ambiguity there, since any negative number squared becomes positive. If you look back at our original equation, yes, 2 squared would equal 4, satisfying the equation, but negative 2 squared would also equal 4 and would also satisfy the equation. And so we have to have that plus or minus based off the ambiguity, and that is a rule for every even type of radical, every even root that we could have. So a 4th root, a 6th root, an 8th root, a 10th root, so on and so forth, those would also need a plus or minus. Let's try looking at this equation in a slightly different way. Instead of saying we want a square root, let's think of a different way that we could try and get x by itself. Now, when we say we're solving for x, which you've probably been saying for years if you're at this point in your math career, when we say we're solving for x, we could also say that we are solving for x to the first power, right? Because anytime we have something that doesn't show us an exponent, we assume it's to the first power. So when I over here on the left say x equals plus or minus 2, we could say x to the first equals plus or minus 2, and that would still be an accurate solution, right? So if we think of it that way, then using properties of exponents that we've talked about earlier, what we could do is we could raise both sides to a power that we specifically choose to cancel out that 2 exponent that's squared. Well, we know from power of a power property that if we have 2 exponents going to the same base, we're supposed to multiply those exponents. So if I raise this x squared to another power, I'd be taking 2 times that power. Meaning the question is, 2 times what would give us x to the first? Well, the reciprocal of 2, aka 1/2, would work in that case. If I take both sides to the 1/2 power, 2 times 1/2, which again is what power of power property says we'd have to do, 2 times 1/2 would cancel out to just x to the first power, which would mean we have the answer we're looking for. We just have to figure out what 4 to the 1/2 power is. Well, taking something to the 1/2 power is the same thing as squaring it, because what we're effectively saying when we say 4 to the 1/2 is we have a 4 to the first power, remember numerator of 1 is the regular exponent, with a denominator of 2, meaning we are doing a second root, or square rooting. And 4 to the first is 4, and the square root of 4 is 2. But we would still want that plus or minus, because solving this problem a different way doesn't change the fact that our answers should be exactly the same. And so I wanted to point this out to reiterate what we've already discussed in the past, that if you have an even root, you need to have a plus or minus. Now if the root is odd, you do not. And so specifically for this lesson, what I'm saying is, if the denominator of your exponent, which represents the root, is even, you need a plus or minus. If the denominator of your exponent, which represents your root, is odd, you don't. So let's solve a couple equations using this concept. So if I give you an equation like this, x to the 3/2 equals 27, and I say we want to solve this out, well, when we're saying we want to solve this out, or we want to solve this for x, we're trying to get to x to the first power. And so the way to do that would be if I take both sides and raise them to the 2/3 power, then that's going to give me the outcome I'm looking for, because, like we said before, power of a power property says that if I have 2 exponents going to the same base, I'm supposed to multiply those exponents together. And 3/2 times 2/3, this 3/2 times this 2/3 will just cancel out essentially to a nice simple 1. And so then, all we have to do to figure out our answer is actually figure out what 27 to the 2/3 is. And like we discussed, we can change that from exponential form to radical form, and that would be the same thing as the third root of 27 squared. The third root of 27, like we discussed earlier, is 3, and 3 squared would give us 9 for our final answer. We would want to double check and make sure we don't need a plus or minus here, but we do not because our denominator was odd, or in other words, our type of radical, our type of root was odd. So remember, that's okay. We only need a plus or minus when our root is even. Let's try another example. Let's say I gave you x minus 2 to the 2/3 power equals 4. I'm going to center that and just erase some of this. Well, at some point to get x by itself, I'm going to need to add 2 over. But I can't do that yet because the 2 is still inside the parentheses, and everything inside the parentheses is being taken to the 2/3 power. So the first thing I need to do is get rid of that 2/3 exponent, or try and cancel that out. Which means we would need to raise both sides to the reciprocal power, which in this case would be 3/2, the reciprocal of 2/3. So 2/3 times 3/2 is going to cancel out to give us just x minus 2. But now we need to figure out what 4 to the 3/2 is. Well, to change that from exponential form to radical form, that means we would have the square root of 4 to the 3rd power, kind of like we talked about earlier. So whether you want to do 4 to the 3rd or square root 4 first, either way, once you square root and take that answer to the 3rd, or take 4 to the 3rd and then square root, you should get 8 one way or another. So for argument's sake, I guess we'll say you did the square root of 4 is 2 and then did 2 to the 3rd, right? Or we can say you did the square root of 64, it really doesn't matter. But the key is, we did square root here. That is an even root, right? We had an even number for our denominator, or it's a square root, so this is an even root. Remember, if we put a number, it's a second. So that means this needs to be plus or minus 8. And the catch with that then is when we go to solve this problem, I do want to add 2 over, but we need to do that with both positive and negative 8, meaning I'm going to have 2 answers here. When I take positive 8 plus 2, I get x equals 10. When I take negative 8 plus 2, I would get x equals negative 6. So both of those should be my answers.